Let's be honest. The industry is rough right now. Companies are cutting junior and mid-level engineering roles. They're leaning on AI to do what developers used to do. If you're trying to break into this field, or if you're early in your career, the advice that used to work isn't really working anymore. The common story right now is that AI is replacing junior developers. Entry-level jobs are down, graduate hiring is down, and the explanation everyone reaches for is AI does what juniors used to do, so companies don't need juniors anymore. I think that's the wrong diagnosis. I think it's completely missing what the actual role and benefits of the junior role in companies are, and I wrote all about that in a blog post, a link in the description. In this video, I want to focus on something more specific. If you're someone trying to break into this field, or someone who's in it but feels like the ground keeps shifting, the answer isn't to give up. The answer isn't even to get better at prompting AI. The answer is to become the kind of developer that AI makes more powerful instead of less relevant. AI doesn't make bad developers better. It makes good developers faster. It amplifies what's already there. Strong teams got more efficient. Struggling teams got more efficiently stuck. The tool didn't change the underlying dynamic, it accelerated it. AI isn't neutral, it amplifies whatever you bring to it, including the gaps. If you have a solid understanding of the system you're building, how the pieces fit together, what the constraints are, what failure looks like, AI can be truly powerful. It speeds up the work you already understand. But if you don't have that understanding yet, AI doesn't say, "I'm not sure." It generates, plausibly structured, syntactically correct, confidently presented, and potentially wrong in ways that won't show up until the system is under real load. The output looks right. It might even pass tests. You won't know it's wrong until production tells you. And here's the part I think is really important, and that a lot of senior engineers don't say out loud. When we tell developers just use AI tools, that advice lands completely differently depending on who's hearing it. Senior engineers can let AI run and then check the work because we have enough experience to know what to look for when we do. We've felt what it's like when a solution works in a demo and falls apart when real users use it. We know which kinds of problems AI get confidently wrong because we've been wrong about those same problems ourselves. That experience is what makes it possible to actually catch the mistakes. A developer who hasn't built that experience yet isn't in that position. And that's not a criticism, that's just where you are. Without that foundation, what looks like checking the work is really just second look at output you don't fully have the tools to evaluate yet. You'll catch the obviously wrong answers, but you'll miss the subtle ones, and AI produces the subtle kind far more often. Now, this isn't an argument against using AI. It's an argument for building the foundation that makes AI actually work for you, rather than just making your mistakes faster and more confident looking. And here's the question I keep getting asked, and honestly, it's the right question. How are you supposed to build that experience if nobody's hiring you to build it? And the honest answer is, yeah, it's harder now than it used to be. But it's not impossible. And I think it's worth being honest about why, because understanding why changes what you can do about it. That mental model we keep talking about, it has a name. It's called systems thinking. It means understanding how things fit together at a higher level. Not just what your code does, but why it's designed that way. What happens when something changes? What breaks under pressure and what doesn't? How your pieces connect to everything around it. That's what you get with experience. For most of the industry's history, systems architecture, the practical, hands-on side of systems thinking, was treated as something you grew into, not something you started with. It lived in staff engineers' job description, in architecture review boards, in conversations you got invited to after you've been around long enough. The unspoken assumption was, first you learn to write code, and then eventually after enough years you learn to think about systems. That framing had consequence. Systems thinking was never urgent for junior developers. It was a destination, not a starting point. And because it wasn't urgent, it wasn't explicit. It got left to osmosis, something you just pick up by being around the right people and the right problems long enough. Now, I have a lot to say about how we used to do that. I always thought systems thinking is something we should be teaching and learning from the start, adjusting and growing as we go. But the industry didn't really focus on that for developers who are just starting out. The way most developers used to build systems thinking wasn't really through early formal training. It happened through exposure, bugs that turned out to be caused by something 3 layers away, features that broke something seemingly unrelated, watching senior engineers argue about a design decision and slowly understanding why it mattered. Nobody sat you down and taught it, you just accumulated it. Over time, through enough of those moments, experiences started to form. AI compressed that timeline. The gap between "I don't have that skill" and "this is now a serious problem" got much shorter. And at the same time, the industry pulled back the very environment where these skills used to get built. The junior roles, the mentorship, the time to be wrong in low-stakes environments. So the condition that used to build judgment quietly got removed. Nobody announced it, nobody designed it that way, it's just what happened. Now, there's an old joke in computer science education. You spend a semester on binary trees, sorting algorithms, graph traversals. You get the job, you never use any of that again. And if you ever do need to use it, you just look it up. The joke is right about the content, but it's completely wrong about what was actually happening while you learned it. The algorithms were never the point. The struggle was. Working through something you couldn't immediately solve was building something. The debugging instinct. The pattern recognition, the ability to sit with, "I have no idea what's happening here," long enough to actually figure it out rather than just guess. The tree traversal wasn't the point. Struggling through the tree traversal was the point. If that just reframes something for you, that's what the subscribe button is for. AI removes the struggle. Not on purpose, it's doing exactly what it's supposed to do. It gives you the answer. But for someone who hasn't yet built the instincts that struggling would have produced, that's not just a shortcut around the content, it's a shortcut around the process that builds judgment. Okay, so the conditions that used to build this skill have been disrupted. The industry stopped creating the environments where it used to develop more naturally. And AI makes the gap between "I don't have this yet" and "this is now a problem" much shorter than it used to be. So what can you actually do about it? Well, here's the thing. Systems thinking is something you can learn. It always has been. The urgency to learn it explicitly just didn't exist until now. And unlike syntax, which you can pick up from tutorial in an afternoon, systems thinking is built from practice. From deliberately putting yourself in situations where you have to think about the bigger picture. Which means you can build it. It just won't happen by accident anymore. You have to go get it. There's a bunch of systems thinking and systems architecture courses and books out there, and many of them are great, and I highly recommend reading them to get a good starting point. But the books and courses alone can't give you the experience you need to really utilize these things. They give you a jump start. So here are a couple of practical things you can do today in the age of AI. When AI gives you something you don't understand, that's the assignment. The easy thing is to test it, see it works, and ship it. And I get it. You're under pressure. It works. Move on. Try to resist that. Not always. Obviously not at the cost of your job, but as a deliberate habit. Treat code you don't understand as a learning target, not a finished product. Before you move on, try to write 2 or 3 sentences about what the code assumes. What does it expect to be true? What breaks if the database is slow? What happens if it runs twice at the same time? What does it connect to that you haven't thought about yet? If you can't write those sentences, you don't understand it well enough to own it. And you will eventually need to own it. At 2 a.m. when it breaks in production and AI gives you 3 confident suggestions that all make it worse. A material's strength isn't defined by how it behaves under normal conditions. It's defined by how it fails under stress. Software systems work exactly the same way. The happy path, the version where everything goes right, is easy. Everyone builds the happy path. The question that separates developers who understand systems from one who don't is, what happens when things go wrong? What happens when the database is slow? What happens when third-party service you depend on returns an error? When 2 users hit the same record at the same time? When the input is technically valid but makes no sense? For any feature you build, try to write down the failure modes before you write the implementation. What are the 3 most likely ways this breaks? Where does it fail loudly versus quietly? Who finds out when it breaks, and how fast? This is what good code review actually looks like. Not does the syntax work, but what does this assume and what happens when that assumption is wrong? If you can describe what a system does, but not why it was designed that way, you don't fully understand it yet. What problems was it solving? What constraints shaped the design? What would change if those constraints were different? Go find out. Ask a senior engineer. Read the Git history. Find the PR where it was built and read the comments. This also makes you dramatically better at using AI. The prompt, here's what I'm building. Here's why it's designed this way. Here's the constraint I'm working within, gets you a much better output than write me a function that does X. Context is everything, and building the habit of knowing your context makes you better at your job and better at directing AI at the same time. Architecture decision records, postmortems, design docs, old pull request threads with long comment chains. These are where systems thinking gets made explicit, where someone had to write down not just what they were building, but why, what they tried that didn't work, what they were uncertain about. They're the institutional memory that doesn't live in the code itself. Reading them teaches you to think in the same register that senior engineers think in. And they show you something important, that the senior engineers you're working with have also been wrong, have shipped things that broke, have made decisions under uncertainty that they later reconsidered. That's not discouraging, it's clarifying. That is what the job looks like at every level. If your company doesn't have these documents, start writing them yourself. A one-paragraph note on why you made a decision is worth more than 10 lines of comments. Once you have even a partial, uncertain, probably wrong in some places, understanding of a system, AI becomes a truly useful thinking tool, because you can use it as an adversary. Here's how I think the system works. What am I missing? What breaks under load? What would a senior engineer push back on in a review of this? That's a completely different interaction than write me a function. It's using AI to find gaps in your own thinking before production finds them for you. And production will find them for you. It always does. AI amplifies whatever you bring to it. Bring a developing understanding and interrogate it, AI becomes a lever. Bring nothing, and it fills the gap with confident-sounding noise. The role that's surviving in this industry, the one that's actually growing quietly in the employment data, isn't the developer who writes the most code. It's the developer who understands what they're building well enough to direct and validate the tools that write it. That's a different job than what a lot of people trained for. And the conditions that used to get you there, the mentorship, the junior roles, the time to be wrong in low-stakes situations, have been quietly disrupted. Which means you have to be more deliberate about building those skills than any previous generation of developers had to be. That's harder. And we should be honest about that. But that deliberateness, that habit of understanding what you're building, not just shipping it, that's not a workaround for the current market. That's exactly what the job now requires. It always was the path to actually growing as an engineer. Today's industry just lowered the threshold and cut the timeline. Every senior engineer you admire didn't start out knowing any of this. They built this experience through broken deployments, bad decisions, production incidents at 2 a.m., years of slowly building a picture of how systems actually behave. You have less time and fewer built-in opportunities to do that the way they did. So you have to be intentional about it in a way they didn't necessarily have to be. That's a harder starting point. But it's also, if you actually do it, a better path forward. So go break something on purpose. In a low-stakes environment, don't get fired. Read a postmortem. Ask why something works in the way it does and actually wait for the answer. The field needs developers who can think about systems, not just developers who can generate code. That's where this is going. If this resonates, whether you're a developer trying to figure out your next move, a senior engineer watching this going, I didn't even notice the amount of experience I rely on, or someone who's been vibe coding their way through and just realized there's a layer that they've been skipping, hit the like button. It genuinely helps me get this in front of more people who need to hear it. And the YouTube algorithm, unlike the AI tools we've been talking about, has absolutely no mental model of anything. It just counts. So help it count. Leave a comment and tell me where you are in this. Drop a brain emoji if you're actively working on building your systems thinking right now. Drop a money bag emoji if you're the person who did the math and stopped hiring juniors. Or just tell me, what's the thing you wish someone had told you earlier about how systems actually work? If you want more of this kind of thing, the human part of software engineering, systems thinking, and yeah, more physics analogies, please subscribe. There's a button somewhere on the screen. The algorithm put it there, so use it. And if you want to go deeper on the industry side of this, so why junior roles are collapsing, what companies are actually cutting when they cut juniors, and why that's going to hurt them in 5 years, I wrote a full blog post about that. Link is in the description. So, go find something to break. Somewhere safe, somewhere low stakes. Learn from it. That's the whole point.